Hi class, welcome to our video lesson on Chapter 5, Lesson 2. We're talking about inequalities in triangles. We're going to refresh your memory on one of the theorems that we talked about earlier in this chapter. It's the exterior angle theorem, or this time it's the exterior angle inequality theorem. Remember, angle 1 here is the exterior angle, and 2 and 3 are the remote interior angles. They're the two angles that are not adjacent, or the ones that do not form a supplement, that form a linear pair with angle 1. So earlier in this chapter, you learned that angle 2 plus angle 3 equals angle 1. So of course, angle 1 has to be bigger than angle 2 here. For this exterior angle inequality theorem is that angle 1 has to be angle 1 has to be greater than angle 2, and angle 1 has to be greater than angle 3. Of course, angle 2 plus angle 3 equals angle 1, so angle 1 has to be bigger than both angle 2 and angle 3. So we have here, if an angle is an exterior angle of a triangle, then its measure is greater than the measure of either of its corresponding remote interior angles. And again, I hope that kind of is common sense. If 2 plus 3 equals angle 1, the measure, then of course angle 1 has to be bigger than angle 2, and angle 1 has to be bigger than angle 3. The exterior angle is bigger than its remote interior angles. The next thing I want to talk about here, and this is very important, it's the location of the angles and the sides in a triangle. So notice on the top left, I have the measure of angle BAC, which is like angle A, the measure of ABC, which is angle B, and the measure of ACB, which is the measure of angle C. 45, 106, and 30. And then I have the lengths of the three sides, 6.5, 8.9, 4.6. Notice how angle C is the smallest angle in measure. It's 30 degrees. And opposite angle C is AB, and it is the shortest length, 4.6. So the angle and its opposite side are both the smallest. Notice the largest angle. It's angle B. It's at 106 degrees. Where's the longest side in the triangle? It's side CA. It's opposite angle B. And then the medium angle is angle A. And notice how opposite angle A is the medium side length. Now, is that coincidence, or does it always happen that way? It always happens that way. I could change this if I wanted to. Let's make angle C very, very acute. Okay, angle C is very, very acute. How big is angle C? Angle C is 6 degrees. Notice the opposite side of angle C is a very small length. It's the smallest one of 2.1 centimeters. Okay, so opposite the smallest angle is the smallest side. Let's make angle A very obtuse. If we make A extremely obtuse, right, angle A is 158 degrees. Notice the side that's opposite angle A, it's side BC. It is clearly the longest side at 29.1 centimeters. So the relationship here is opposite the largest or the biggest angle is the biggest side. The smallest, the middle angle opposite that is the medium or the middle side. And the smallest angle is opposite the smallest side. That's the relationship that there is in every single triangle. So in the exact opposite way, the biggest side is opposite the biggest angle, the medium side is opposite the medium angle, and the smallest side is opposite the smallest angle. So those are those relationships. All right, let's get into a few example problems. The first two deal with the remote exterior angle theorem. So it says, which angles are less than the measure of angle 14? So I'm just going to underline angle 14 here. And let's talk about all the angles that we know are less than 14. Now we can't go by what the picture looks like. We have to go by the exterior angle inequality theorem. So there might be others that are smaller in measure. That's what we're looking for, right? Or less in measure than angle 14. But we're only going to write down the ones that we know for certain. I'm first going to make this triangle. 14 is the exterior angle. The remote interior angles are angle 11 and angle 4. So we know that angle 11 and angle 4 are less in measure than angle 14 because angle 4 plus angle 11 equals 14. What you might notice now is that angle 9 is the vertical angle to angle 11. So angle 9 is also less in measure than angle 14. So now what I'm going to do, class, is I am going to make this triangle, because angle 14 is also the exterior angle for the triangle I just drew in green right there. And so what are the remote interior angles? Angle 2 and angle 3 and 4. And we already circled 4, and if 3 and 4 together are less than angle 14, then of course angle 3 is less than 14. So there is 2 more, angle 3 and angle 4. I made, let's see here, I said the measure of angle 4 twice, didn't I? The measure of angle 2 and the measure of angle 3 are the angles that we were looking for on that one. All right, and then there's actually 2 more here. We said angle 11 was a remote interior to angle 14. So angle 11 is smaller than angle 14. And notice how angle 11 is an exterior angle to angles 6 and angles 7. So if 11 is less than 14, then the degree of 6 and 7 are less than 11. So of course 6 and 7 would also have to be less than 14. So those are our last 2 angles that we're going to have here for this one, angle 6 and angle 7. There might be others if we took a protractor and measured it or something like that, but these are all the angles that we know because of the remote exterior inequality angle theorem. So let's try one more with this. This time it says which angles are greater than the measure of angle 5. So angle 5 is right here. So the angles that are bigger than angle 5, or greater in measure, again, I'm going to draw this triangle right here. And I guess it would be this one here, sorry. There we go. Angle 17 is an exterior angle, and 11 and 5 are the remote interior angles. So angle 17 would have to be greater than angle 5 because it's the remote exterior angle. So there's one of them. I could also draw this same triangle and have angle 10 be the exterior angle, and 4 and 5 are the remote interior angles. So 10 is larger than angle 5. And notice, so far we have 17 and we have 10. Notice how, again, 12 is the vertical angle. So 10 and 12 are congruent. If 10 is bigger than angle 5, then the congruent angle, angle 12, is going to be greater than angle 5. So 17, 10, and 12 so far. So let's see. Now that we have this, if we, let me think here. I think there's a couple more. And yes, here we go. If we have angle 10 being bigger than angle 5, and if we were to draw this triangle right here, 16 is the exterior angle where 10 and 2 are the remote interior angles. So 16 has to be bigger than 10. And if 10 is bigger than 5, then of course angle 16 is bigger than 5. And we're going to have that exact same method with angle 15 here. We already know that angle 12 is bigger than angle 5. So if angle 12 is bigger than angle 5, and 15 is the exterior angle for angles 12 and angle 7 of that blue triangle that I drew on the right, then 15 has to be bigger than 12. And if 12 is bigger than angle 5, then angle 15 is greater than the measure of angle 5. So that's everything that we can conclude from this picture. Last 2 practice problems deal with how the opposite side, Opposite the smallest angle is the smallest side. Opposite the medium angle is the medium side. And opposite the largest angle is the largest side. So list the sides of the triangle in order from smallest to largest. The triangle is not drawn to scale. So angle H, it looks like it's obtuse. Or sorry, it looks like it's acute, right? If you were to take a protractor, it looks acute. But it's not drawn to scale, so don't think of it as being acute. No, just look at what the numbers that I give you. I give you that it's 100 degrees. Even though that's an obtuse angle and it looks acute, we're going to assume that it's 100 degrees. So if it's list the sides from smallest to largest, I got to look for the smallest angle. 33, you are the smallest angle. So opposite that, LH, that segment is the smallest side. Next one is the medium. Well, the medium angle is 47 degrees, so opposite the medium angle is the medium side. JH, even though it looks like it's the largest side, we're saying it's the medium side because the triangle is not drawn to scale. The largest angle is 100 degrees, so opposite the largest angle is the largest side. So segment JL is the largest side. Okay? Next one is a very similar problem, just the opposite part of the triangle. Instead of list the sides, we're going to list the angles from smallest to largest. So now we're going to look at the sides. What is the smallest side? Now it's not drawn to scale, so pay attention to the numbers. 7 inches is the smallest side. So opposite that is the smallest angle in degree measure. So angle J, you are the smallest. The medium side is angle 9, so opposite angle 9, or opposite side 9, or opposite RJ is angle C. That is the medium angle. 12 inches is the longest length. So opposite of the longest side is the biggest angle, angle R. And that concludes our lesson on 5-2. Let me know if you have any questions when you get to class tomorrow.